All right, welcome back for a little bonus video. This is that last example that I ran out of time for in the original lesson. So let's take a look at it. Again, you probably don't really need this to get through today's homework, but it might give you a little sneak preview of some things we're going to talk about in the next lesson. So I've got r equals 1 minus sine theta, and I don't really know what this is going to look like in my graph, so I think I'll start by changing it to a rectangular equation like it suggests. So I think I'm going to try multiplying r on both sides. I think squaring both sides is going to get kind of messy because I'll have to FOIL and I'll have a sine squared, and that doesn't look too familiar to me. So if I multiply both sides by r, I'm going to get r squared equals r times 1 minus sine theta. And if I distribute that, that becomes r minus r sine theta. And I still have r squared over here. So then we can use some of those substitutions we learned back in lesson 9.1. We could do x squared plus y squared for r squared. And then r becomes root x plus y. And then r sine is minus y. Well, unfortunately, while maybe I accomplished my goal, I was able to transform it to a rectangular equation. When I look at this doesn't really strike any familiarity to me. Like I don't see this and know, oh, that's a line, or oh, that's a circle, or anything familiar at all. And so maybe that wasn't quite as helpful as I had hoped. And so we have to kind of come up with a backup plan. And so I'm going to use the same backup plan I've been using, or maybe you've been using, or we've all been using since maybe about middle school, 6th or 7th grade, when we first started graphing equations. And that very first strategy that we ever used was a good old input-output table. And so what I'm going to do is I'm going to go back to my original equation, r equals 1 minus sine theta, and I'm going to try some inputs and outputs and see if we can get some sort of idea of what this graph looks like. So anytime I graph something new and I'm going to pick some inputs, I'm going to try to pick some friendly inputs. So the friendliest inputs I could think of are my quadrantal angles, like 0, pi, pi over 2, 3 pi over 2. So I think I'm going to start with those and see where that takes me. So if I plug in a 0, sine of 0 is 0, and 1 minus 0 is 1. And so maybe I'll come on over here and graph that. So angle of 0, again, we should always start with our polar axis. And so if my angle is 0, I'm going to go along that axis and r value of 1. So I'll put my first point right here. And then I'm going to try, how about let's do pi over 2. That's a pretty friendly one. And the sine value of pi over 2 is 1, and 1 minus 1 is 0. And so that's going to give me an interesting point. You know, at pi over 2, I'm heading this direction, but I'm heading that direction 0 units. And so my point is actually going to stay right here at the pole, or what would be 0, 0. All right, so then I'm going to move along to the next friendly one. Pi is a good one. The sine of pi is also 0. And so 1 minus 0 will be 1, just like 0 was 1. But this time, it's not going to be this point. It's heading in this direction towards pi. So towards pi, 1 unit is going to put me right here. And then how about let's try 3 pi over 2. And I have kind of a suspicion what's going to happen here. The sine of 3 pi over 2 is negative 1. And 1 minus negative 1 is actually going to be plus 1. 1 plus 1 makes 2. So this is kind of interesting. Instead of 0, when I go towards 3 pi over 2, I'm actually going to go down 2 units. I'm going to go right here and put a point. Okay, now this is, it's interesting. I've got some points. I've got a good start here, but it doesn't really tell me what's happening. You know, my best guess at this point is what is going on? Like, is it a triangle? Like, should I just connect the points this way and make a triangle? I don't think so. I don't have anything in our history that tells me that a sine graph is going to be a triangle. So I think what that means is we just need to try some more points. And so let's try to pick some other points that are maybe familiar or friendly to us. So I'm kind of thinking pi over 6 has a friendly sine value that we could use. Pi over 6, we know the sine of pi over 6 is 1/2. And so 1 minus a half will be a half. So, not as friendly as these points, but still, doable. So pi over 6, and then I go 1/2 a unit. So that's going to put me right about here. And then I'm thinking if pi over 6 is a friendly value, then 5 pi over 6 is also going to be friendly. That one's going to also be 1/2. Is that right? We're going up. You think about your unit circle, the same distance as we do for pi over 6. So 5 pi over 6 will also be 1/2. 1 minus a half is a half. And so I'm going to place that point over here as best as I can. And then, oh, I think I need to fix one of my points here. It looks like this point that I thought I put at pi over 6, I actually put on pi over 12. So I'm going to slide that and put that right in there. There we go. That looks better. And then I'm thinking another friendly value is going to be perhaps like negative pi over 6 or negative 5 pi over 6. See if we can squeeze just a couple more on there. And the reason I'm choosing all of these is because, again, these have sine values of a half, or in this case, negative a half. I'm trying to avoid the sine values of root 2 over 2 or root 3 over 2, because those are going to be a little bit less friendly to graph. I could graph them, maybe use my calculator to get a good estimation, but I think the values that I've chosen here are going to be a lot friendlier. So negative pi over 6, that's going to be negative 1/2 for sine. So 1 minus negative 1/2 will be 3/2 or 1.5. And if I were to graph that one, negative pi over 6, so I'm going to go backwards to 11 pi over 6, or what negative pi over 6 would be, and I'm going to travel a distance of 1.5 units. So 1.5 is going to put me right about here. And then if I do the same thing for negative 5 pi over 6, that's going to take me over here. And again, if I travel 1.5 units, so 1 plus a half is going to take me right about here. Okay. So if I wanted to, I could keep creating more points. I kind of feel like I have at least a general idea of what's going to happen here. And if I just maybe at this point kind of connect the dots, not like in line segments, but with some curvature, kind of like a circle might be curved. I'm kind of thinking it's going to look a little something like this. I'll do the same thing to the other side. And what we end up with is a brand new graph that we've never graphed before. You'll notice it kind of is heart-shaped. And in fact, the name of this graph might remind you of a heart. The name of this graph is a cardioid. So thank you again for tuning in for our little bonus video here. One thing I might throw at you is that, again, this is kind of maybe a teaser for the next lesson. So we'll talk more in depth about cardioids in our next lesson, and I'm also going to show you, or we're going to discover together some other figures that will be brand new to you. If you happen to have your graphing calculator handy, you might dust that off, and we might do some exploring with our next lesson. So if you have that handy, that could be useful. If you don't, if you happen to have left it at school or in your locker or whatnot, I think you'll be able to survive without it, but it might be kind of fun to play around and just do a little bit of exploring as we look at some new graphs. So until next time, Thank you again for tuning in, and if you have any questions, please reach out.